chill out and get ready for a it's time to chill out and get ready for a mediocre Q&A live stream. If you're old enough, grab yourself your favorite adult beverage, and if you're not, stick with apple juice. Put your feet up and relax. If you have any questions, feel free to ask them in the chat. And now let's cue up the intro music. Hey everybody, welcome to the HVACR videos live stream. It's been a while. It's been about a month. I realized that when I was scheduling the stream, I was like, wow, I haven't done a stream since the beginning of the month, and it's pretty much the last Monday of the month. So yeah, here we are. It's been chaotic lately. I'm sure you guys all are dealing with the same stuff as I am, but summer turned on about 30 days ago, and it was just like a brick wall. Whoa, hit us hard. And lots of craziness going on with work, with customers, things like that. Bunch of changes happening. So it was a pretty stressful month, but I'm here. I'm alive. I woke up this morning. I'm thankful for that. And yeah, let's get on with this. So as usual, I do these live streams to kind of consolidate questions, answer things in a live format. I kind of beat to the tune of my own drum. So I do have a bunch of questions. We'll see what I can get to. If you guys have things you want me to cover, feel free to put it in the chat in all caps lock, please. It'll help me to realize that you're actually talking to me. I encourage you guys to have the conversations that you're already having. And for the regulars that are in the chat right now, before I go into that, let's address this. If you're watching this on Facebook or LinkedIn, perfect. That's awesome. But just so that you know, there is a large community of people in YouTube right now, and there's a giant chat going on with lots of people having conversations. So if you want to be part of that conversation, jump on over to YouTube. Again, HVACR videos on any platform. But I don't get any benefit from you watching on YouTube, LinkedIn, or Facebook. Watch anywhere you want. I'm just saying there's a whole community and a conversation going on YouTube. I encourage those conversations. There's a whole community of people that literally are helping each other within this live stream in the chat. So of course I encourage that. So that's why if you guys do have things that you want me to cover, I ask you to put them in all capital letters, because it kind of helps me to make sure, or to be able to recognize that the conversation is meant for me. Also, guaranteed this is going to happen, there's going to be stuff that I can't cover. There's going to be comments that I have on my list that I can't cover because I've only got about 45 minutes on this. So feel free to shoot me an email if I miss your question or don't answer your question. It's hvacrvideos@gmail.com, and I'll try to get back with you as soon as I can. Again, life has been crazy. So welcome to the show. I hope you guys are all doing well. Hello to everybody. There's lots of great people in here, I see. Lots of regulars, lots of new people. Hello, welcome to the stream. So again, the point of this is to kind of consolidate questions from my videos and then also answer stuff in a live format. You know, like I said, things have been chaotic at work. Things have been crazy. Just before summer hit, you know, I was going through like, you know, annual physicals and stuff. So I've been having to make changes to my diet and different things like that. And the reason why I bring that up is because as we're going into the summertime, or as we're in the middle of summer, we have to remember that you got to take care of yourself. I am talking to myself just as much as I'm talking to you guys, because I constantly get caught in the routine of, I'm just going to finish this. I'm just going to power through this, and I'm going to get to this, and then I'll deal with food later, right? That always sounds great at about 10 a.m. when I think I'm just going to power through lunch. And then next thing you know, it's 5 or 6 p.m. And then I realize, oh my gosh, I worked through the entire day and I didn't eat a single thing. You know, I just drank water or whatever. Take care of your bodies. Obviously, that's a bad thing to do to yourself. Don't be like me. Okay. Be smart. Take care of your bodies. Drink lots of fluids. Take care of all the stuff, the nutrients and everything that you need, because you want to be able to go home to your family at night, and you don't want to be broken. Okay. So I have a bunch, since I, you know, haven't done a stream since the beginning of the month. You know, there's going to be a bunch of stuff. I'm going to start with the newest videos, and then we're going to work our way back and see what we can get to as far as questions and comments. So I had a video where I said the kitchen AC wouldn't keep up. We obviously had a lot of maintenance issues with that particular 15-ton package unit, but then there was some refrigeration issues too. I encourage you guys to go check out the video. It shows you the systematic way that I troubleshoot things and approach things. Pretty much for the most part, do that identical thing that you see in the video when the camera's not rolling. And I've been doing a lot of work lately just because we've been so hectic, where I haven't been filming calls. Some of my better service calls that I've had that turned into compressor changeouts and complicated issues, I didn't even film. And that's the bummer. Sometimes I wish I could film everything and then just decide later, but sometimes you just get so crazy. But anyways, I had a video called The Kitchen AC Won't Keep Up, where the unit ended up having a bunch of issues, right? A lot of people are asking on this video and on other ones, but they're saying, hey, why is it that I always pipe the condensate drain into the sewage system? Okay. And I specify by saying going into the sewage system, because technically we're supposed to pipe our condensate into the sewage system. So that way the condensate drain off can be properly processed and cleaned. Because if our water in the state of California is not turned into irrigation water or drinking water, then it goes back to the ocean. Okay. We are very conscious about our oceans here, and we try to be very proactive about keeping them clean. So one of the reasons why we have to plumb our condensate into the sewer is that way it can be properly processed at a sewage treatment plant to make sure that that water doesn't have anything bad in it. Okay. But in general, that's what we try to do as much as possible. We pipe our condensate into the sewers. Sometimes you'll see people doing it into like roof drains, but roof drains typically will have, at least in Southern California, you'll have a roof pit drain on the roof, right? It's like a small pit drop down about 4 inches or something. There'll typically be 2 drains in there. There'll be one going directly to the sewer, and then if the sewer one backs up, then it overflows and then goes down the gutter drain and drains down the side of the building. So they prefer us not to drain our condensate onto the building for that reason, because eventually it can make it outside and they want to process it and clean it. So a lot of people ask me that question all the time. Why in the heck do I use copper drain lines on everything? Because it lasts forever unless the tweakers steal it. So PVC with the sun here, the way that it hits it, even if you have, you know, the fancy PVC that has the UV crap in it that doesn't rot as fast or whatever, it still rots. Okay. I have a PVC drain line on the side of my house that for my irrigation system. And over the weekend, it literally had 1, 2, 3, 4. It was 5 different pinhole leaks on the threaded portion, nowhere near where it threaded into a fitting. Like, it's just the PVC deteriorating, because that was in the house when I moved into it 10, 12 years ago, whatever it was already there, and it's just been getting baked by the sun. The PVC just doesn't last as long, in my opinion here. PVC is pretty common on the residential side, but on the commercial side, when it comes to like the restaurants that I'm dealing with, PVC is not very common. Another problem that we run into, again, the way my life works and my motto and the way that my brain works is I always assume the worst in things. You can call me a pessimist, okay? But my logic in my head is that if it can happen, it will happen. So if it can, it will. And when you are dragging water hoses across the roof, we use, regular rubber water hoses. If you're not paying attention, you're dragging around the side of a package unit. Number one, that's a really bad idea because our roofs typically have like a roof tar that's painted and has some gravel on it. And if you drag your hoses across things on the roof, you'll stretch it through the warm roof tar and it'll kind of make its way through some things. And then that can be a nasty problem too. But when you drag those hoses around the corner and you have PVC that's been sitting in the sun forever, it becomes very brittle. And I've seen drain lines snap because people just pulled a hose too hard against it, right? When they were PVC. So PVC is just not very popular with me, and it's not very popular in general on the commercial side in the restaurants that I deal with in California. Another person asked in that same video, the kitchen AC won't keep up. And I mentioned in that video that we had a plugged up liquid line filter dryer. Okay. And I kind of talked about it a little bit, but my opinion on why the filter dryer plugged up was because we did a compressor change on that system about 2 years ago, I think, or something like that. You guys may remember because I think it said it in the video, but it's probably about 2 years ago. And we changed the R22 compressor to a newer compressor that had polyester oil in it, right? Polyester oil acts as a solvent within our refrigeration systems. In the right conditions, with the right temperature, the right pressure, when that polyester oil goes through the system, it acts like a flush or a solvent, and it scrubs the pipes of that wall or of the walls of the pipe, right? Typical systems that were mineral oil before, they didn't really have this issue. So when you start to have contamination issues in the system from brazing without nitrogen, from overheating oil, from not doing normal routine maintenance with plugged up condensers, that leads to overheating oil. Okay, that kind of stuff can leave sludge and different things throughout the pipe. And when we change over to polyester, that polyester flows through the system and scrubs the wall of the pipes. So when you have systems that have been severely contaminated and you do a compressor change to polyester oil, you can pretty much assume within the next year or two, you're probably going to have to go out there and change a filter dryer. And that's exactly what I had to happen. Okay. Now this gentleman is asking me a question. The Secret 101 is his name. And he said, would it be a good idea to flush the old system using a liquid like alcohol and a circulation pump, right? Is what he's asking me. And no, that wouldn't be a good idea because refrigeration systems, they're very sensitive to other components that are in the system. And using flushes and solvents and different things, the question I have for a solvent or a flush is, the gas portion of it will evaporate, right? When you're doing an evacuation, it'll evaporate and leave the system potentially, right? But what about any other things that were in the liquid? What about anything left over? Where does that go and what does it do? Is there anything left over? I know the manufacturer says no, but it's hard for me to understand that. When you put a chemical into a system, and it mixes with oils and different things and you're flushing out the system, how do we know that that's not getting trapped in the system and then leading to a contamination issue later? Okay. Flowing different things like that, it would just be a problem. And then evacuating it. Is it truly just pure alcohol that you're using if you were flushing with alcohol or something? I mean, it's just not best practice to do that. There is companies out there that make flushes. I personally don't use flushes, but there's a lot of people probably in the chat. And I will even go out and, and be honest and say that the very beginning of my career, for a good majority of it, we used to use flushes. We used to put acid neutralizers in every compressor change out just to be safe because, whatever. And, we were told that it was safe. We were told that it was fine. I don't recall any major issues that we had with those. But then again, I wasn't as skilled. So maybe I wasn't understanding that, all these different compressor changes we were doing were potentially caused by those. I don't know. I don't remember much about that. Right. But I will say that I did use flushes and additives and different things, again, for the first part of my career. I just choose not to now. My personal preference, again, you do you, is that I only put the refrigerant, the oil that's supposed to be in there, And that's all that I really want to put in the system, if not nitrogen when I'm testing the system or something, right? But I want to do a proper evacuation and just use refrigerant and not add any additives. That's my personal preference. Again, you do you if you do differently. Okay, it's okay. No big deal. We don't got to hate each other for that reason. All right. Again, hello to everybody. Ike, what is up, my good friend? So Ike says he cannot believe that he's been a supporter for 4 years. Yeah, it's been a long time. Ike has been a supporter of this for a very long time. Ike actually runs a Discord server for the HVACR videos platform, and you guys are free to check it out. Ike can throw a link in the chat if you guys are interested in joining the Discord server. It's a heavily moderated Discord server that talks about HVACR, and then they have other different rooms and stuff. To be honest, I have not been in there in a very long time. I really should try to get in there. Maybe message me or something. I can remind me, and I'll try to start at least coming in there every once in a while and saying hi to everybody. But definitely throw the link in there, Ike, so everybody can join if they want to. Let's see what else we got going on here. Richie Rossbach says, sorry if I butchered your name, okay? He says, so no acid eliminator after a burnout. No, my personal preference is, you know, nowadays, again, in the beginning part of my career, I used acid stuff all the time, right? I personally don't. So if I have a burnout on a compressor, what I'm going to do is I'm going to take the compressor out of the system. And then if it's a severe burnout, this is my personal preference. This doesn't mean you have to do it this way. Okay. This is just how I approach things. So take the compressor out of the system and isolate major components in the system. So what I mean by that is I'll cut the condenser out of the picture. I'll cut the evaporator out of the picture, and I'll flush the lines to each one using nitrogen. Okay. Blasting through the lines, just seeing if I could get anything out of it. And then once I do that, I'll decide, depending on the severity, if I'm going to install a suction line filter dryer and a liquid line filter dryer, or just a liquid line filter dryer. I try to stay away from the suction line filter dryers a lot lately. I haven't been selling very many of them just because they're a massive added cost. And in all honesty, most of the contamination issues that I'm noticing are being cleaned up by the liquid line filter dryer, and the suction line filter dryer really isn't doing a whole lot for me. I know it's a protection device, but there's a lot of risks in installing suction line filter dryers. So I've been trying to lay off them as much as possible. But if I get a severe burnout, I'll probably put one in. But the best thing about putting suction line filter dryers in is most of the time they have double ports on each outlet, so you can check for a pressure drop across the suction line filter. And, you know, another good thing too is, or another important thing to remember, and I know I'm going off on a tangent talking about these refrigerant additives and stuff, but another thing to remember is that on a suction line filter dryer, and I've made this mistake several times in videos, and many people have corrected me and reminded me that you cannot really tech a temperature drop across a suction line filter dryer because there's no refrigerant state change happening through that area, and it's not liquid on one side, right? So typically coming into the suction dryer is vapor, coming out of it's vapor. If you had liquid, like you do in the liquid line filter dryer, pushing through the dryer and it was restricted and it was coming out vapor, well, then you'd be able to feel the change, right? And that's the temperature drop we look for when we're coming on the liquid line filter dryers. But on the suction line filter dryers, you really can't check for a temp drop. It's going to be so minute that you're going to see pressure drop only. Lean on the manufacturer of those suction line filter dryers. Typically, what you're going to see is anything from 3 to 5 PSI. It's time to change it. On the lower end is better. Any restriction in the system is a problem because it slows down oil movement and different things through the system, changes the refrigerant velocity, so it leads to problems. So back to the question, do I use any additives when I'm doing burnouts? Not really. Okay. Sorry for the long answer there. Let's see. Al Anonymous is saying Johnson Controls is still screwing up commercial units, making them unusable. Probably I see what he's saying because I made a short, or I made a video showing one of the York package units. Interesting factoid. If you guys have been living under a rock and you didn't hear the news, I think that came out late last week, early this week. And we've kind of known that this was happening, but Johnson Controls actually, or JCI actually sold off its consumer air conditioning division and light commercial air conditioning division to Bosch. And Bosch actually made a cash deal for it. Some crazy and godly amount of money Bosch bought it for. So Bosch now owns York, essentially. I don't know, because they keep stressing residential and light commercial. So it makes me wonder about the heavy industrial division. Are they still going to run their heavy industrial? Which I bet you they're still going to do that. I'm assuming, but maybe someone in the chat can let us know. Okay, let me go through the chat, see what else we got going on in here. Seeing I should install ball valves after compressor burnout, Caden. Yeah, I try to install ball valves when the customer allows it on my filter dryers. You guys probably see it even when it's not a burnout, especially on my customers that don't do routine maintenance. I'm starting to notice a lot of filter dryer plug ups. So yeah, I've been installing a lot of ball valves, one on each side of the dryer. So that way, if the dryer plugs up, then you can easily recover the charge from that little section where the filter dryer is at. With the system off, you can ball valve it out and just vacuum or recover that section, change the dryer, vacuum it down, and then open the refrigerant flow right back through it. So that is a good way to do it. Yeah. All right, let's see what else we got going on in my list of questions. So I had a video where I said contractor of the year goes to, and that was the video where we had a York package unit that had some weird gremlins in the circuit board, dirty condenser. And while I was on the roof, I panned over and I showed that they had several new York units on the roof. And two of them, the curb adapters, are massively bigger than the roof openings. And so a lot of people have a lot of points and comments about that. Steve Covington, I'll answer this question really quick. Would I recommend using a pre-filter along with a regular water filter for an ice machine? Yes, especially if you have contaminant issues, if you have things floating around in your water system. Yeah, for sure. A pre-filter is always a good thing, but you want to pay attention to the pressure drop. You don't want to reduce the pressure too much, and you still want to have the proper GPM of flow going through those filters to make it to the machine, because Hoshizakis are very critical about their water pressure being high enough versus isomatic. For instance, right now, just ran into an isomatic issue that I don't have on film, but we had a issue where the thing was just acting really wonky, kept going off on these water float safeties, and it was just a problem, and we couldn't find anything wrong with it until we realized that the restaurant had a broken water pressure reducer on the system, a water pressure regulator for the building. And it was erratically bringing the water pressure sometimes up to 80, 90 PSI. And that was messing up the way that the water was flowing into the machine, which was jacking with the float. It was a whole thing. So water pressure and water flow and GPM is very important for ice machines. So any filtration you can put on them, do it, as long as it's not going to reduce the water pressure too much. All right, so let me go back to what we were talking about in here. So with the curb adapter video, it's a bummer that the customer did that, but it is what it is. And that happens with some of my customers. I know a lot of people are saying fire them as a customer. I mean, if I wanted to get that crazy, I could, but I'm not going to fire the customer for something like that. It happens in the corporate restaurants. They're still using me for service. They still have trust in me. So you know what? As long as they're not reducing my workload, and like giving it to other people and stuff, I'm still going to stay with them. It's just some, things you got to deal with these chain restaurants. Let's see. Brian Sanders says, check the TDS level in the water to see what you need. And that's a really good point. So, the very interesting thing is all the major ice machine manufacturers sell their own water filters. Okay. Hoshizaki has them, they all pretty much, I should say almost all of them, right, have their own water filter brands that has their name on it, and they get to sell them. Sometimes they're just rebranded other people's filters. But the point that I want to make is that even the ice machine manufacturers are really just in it to make money sometimes. And this proves that, like, they really don't in some ways care about the industry, because their water filters are one type of water filter that filters probably like 80% of the water types out there. Okay. But it's not necessarily the right filter for every different water issue. The only way to know what kind of filters you need on your ice machine is to actually test the water. But to be fair, I've never tested water on an ice machine, okay, because a customer has never wanted me to go that far and been willing to pay me to go that far to have all that stuff done to install those types of water filter systems, okay? But they do exist. And then you can tailor what kind of filtration you have based on your conditions. Most of the time, the customers are buying direct from the manufacturers. They buy whatever cookie cutter approach to water filtration they have, and it just does kind of a half-assed job. Sometimes works, sometimes doesn't, whatever. Water tastes weird, water's cloudy, just all kinds of weird stuff. All right, every water system is different. Reading through the chat. Mr. Hammaster says, literature differs, but have I noticed any damage to a compressor if a 7/8 inch line set is used over the recommended 1 1/8? You have a line set that would be too expensive to change and don't care about the efficiency loss. Mr. Hamster, where I'm going to say that you really need to be careful in that situation is if the new system is going to be you know, an inverter system or a variable system, because the refrigerant flow through those variable capacity systems is very, very important. And without the proper flow, the system will not work right and it will lead to certain failures within the system. So be very cautious about running too small of a line set. But hey, I've done all kinds of things throughout my career where sometimes there's no other option. So you give the customer, this is what it's going to be. To do this, we're going to have to spend this much money, or we can, you know, decide to use a smaller line set, hope that we don't have any problems, and move on. Oftentimes, if you put that in the customer's hands, they actually will choose the easier way to go. And then by them making that decision, you take the liability off yourself. So when there is issues, it's not your problem, right? So if you are going to make those kind of decisions, run it through the customer, make sure that's something they want to do. If they're willing to sign off on it and potentially take the risk of running into issues on an inverter system or something by having a, you know, undersized line set, then let them make those decisions. But I wouldn't make that on your own because you just don't know what kind of problems. But the other things you can run into with refrigerant lines that are undersized. Now, I realize you're saying from 1 1/8 to 7/8, so that's not a lot, but on an inverter system that's ramping up and slowing down, that could mean big changes. Okay. But, you know, why we size lines the way we do is for refrigerant velocity and oil return, because naturally with the refrigerant, as it leaves the compressor as a high temperature, high pressure, superheated vapor, there's going to be droplets of oil that do migrate with the refrigerant. Those droplets of oil can sometimes get stuck in the system, and that's where the refrigerant velocity really comes into play. If you have the proper refrigerant velocity, pushing the refrigerant through the system at the rate that it was designed to be pushed through, then that refrigerant will likely be carrying the oil back to the compressor where it's supposed to be, right? In a perfect world, we put oil separators on every system, but you still have to have some oil flow going through the system. You can't remove all the oil from it because those oils over time do lubricate sensitive components throughout the system, such as thermostatic expansion valves, whether or not you have O-rings in the system, solenoid valves, different things. That refrigerant oil does have some lubricating purposes for the later, you know, the other components in the system too. So it is important to always make sure there's some, so you can't just completely remove all the oil. Okay, now that I went off on that tangent, have I ever just walked away from a job? Yeah, there has been jobs. So I've told these stories before, but there was a very, very large Indian casino near me, and we were called last minute by a contractor that had quoted this job for this Indian casino to install these refrigeration systems. They were using one contractor for the refrigeration systems, one guy for the air conditioning systems, and, you know, everybody else for other stuff. But the refrigeration guy contacted us because he bid on a job and someone dropped out and he needed another company to come in there. And, you know, I should have listened to that red flag when this happened, but in hindsight, you know, we see everything, right? But so I went out, I looked at the job, I talked to the guy that was hiring me, you know, and he was a sub already. It was a weird situation. But anyways, talked to him. He gave me the idea, the scope of work. I looked at it, I quoted it, and we got approved. He said, let's get it done. Then the red tape started. The first day I went to go be on the job site and start doing the work, then I realized, because this was a large contracting firm that was building this addition on this Indian casino, they had a lot of safety regulations. So before myself or any of my techs, we had to go through safety meetings. We had to go through all kinds of proper training to be on the job site, safety vests, hard hats, like rules and regulations, all this different stuff, right? So we literally had like 2 days of training just to be able to do this job, which I didn't even know about. So that was already a red flag, right? Then we got started on the job, looked at it. This was such a cluster F, right? So I started looking, got to the job, and then really started unraveling things and realized how much of a problem this was going to be, because this was the worst organized construction job I'd ever been on. It was insane. Okay. Everybody was just button heads. Nobody was communicating. I rented a scissor lift and I parked the scissor lift plugged into this location, and I came back and it was gone. We spent 3 hours trying to find my scissor lift that someone took and started using somewhere else on the job. Like, it was just one thing after another. When I got into the refrigeration equipment, I realized that they didn't design it right. The equipment that they had shipped to the job wasn't designed for, it was water cooled refrigeration equipment. And it was going to be like 200 feet away from, or 100 feet away from, yeah, it was 100. It was 100 feet away from total equivalent length, 90s and everything. It was going to be 100 feet away from the equipment, the evaporator and the condenser, right? So we had really long line sets. The receivers were way too small. They were like 8-pound receivers. I ended up having to call Omnitemp, the company that won the job for the equipment, and they were like, no, that's supposed to be installed 6 feet away. So they had to make massive changes. So we went through all this stuff, and it was like literally a week's worth of crap of me unraveling all their stuff. And I'm talking to the guy that hired me, dude, price is going up, price is going up, price is going up, because it was just one thing after another, right? And then came time to do all the work. And I showed up, we scheduled it. We went through the security company. We went through the pit boss that was running the casino because we needed him to shut down tables. We had to put scissor lifts in the middle of this casino and do all this stuff to do the work. And the night that I scheduled everything and got everybody's signature on it, I showed up. The pit boss was there. It was a different guy. And he's like, I'm not closing the casino down. And I'm like, dude, this has been scheduled for weeks. There was like, all this stuff. And he's like, we're not shutting the casino down. And I'm like, all right, cool. No problem. I was done, but I didn't tell anybody I was done. Also, I'd heard some weird things about Indian casinos. Hey, you know what? They're probably stereotypes. They're probably whatever. I'm probably completely incorrect, but I heard some things about job materials. And I had a lot of money in job materials stored on this Indian casino. Okay. A lot of money, because this was a big job. And I was worried about getting my stuff because I'd heard some weird rumors, and I just didn't even want to question it. So that night, I didn't mention this either. It was like 4 a.m. when all this was going on, because this was all overnight stuff, right? So I loaded all my materials onto my truck. I looked like the Beverly Hillbillies driving out of that place, and quietly drove away, got off property, returned all my materials, got my money back for those. I waited till the next day. I called the guy that hired me and I said, you got to find someone else. See ya. I'm out, because I walked away from that whole thing. And I was probably, I think we estimated at least $5,000 in labor into that, and like time and stuff that we invested into it. Right. We only lost labor and all that crap, but it was a lot of money in training and everything that we had to go through. And I just walked away from it. So I waited till the next day. I just got my materials and said, see ya. So maybe I was a jerk for doing that, but it just was such a disaster that I was done with it. So let me see what else we got going on in the chat. What am I missing? Mortgage. Okay, cool. No, it was not Pachanga and Temecula. It was I'm not going to name it. I don't know what the rules are with that crap. No, I'm not naming what casino it was. Let's see. Did I oversize the duct to my office to cover the computer heat? It looks fine in here. Well, okay. So it looks fine in here, but how do you know it's not 95 degrees in my office? I do work in the heat all the time. Okay. So maybe I just handle the heat really. No, I did not oversize the ducting into my office. Okay. So for those that are curious, I'm sure most of you guys know, I did a big install series designing the equipment for my house, troubleshooting air leakage problems, installing a new air conditioning system, ductwork, all that different stuff. It's on my channel. If you don't know about it, go check it out. But the question is, did I oversize the ductwork so that way I got more airflow into my office that I'm sitting in right now, because I have a large computer system behind me that puts out a lot of heat? So that's the question. No, I did not. So we thought about it. We thought about designing my air conditioning system for this house with the amount of heat load that is in my office in the picture, right? But what we decided was that if we sized, counting on the heat load in this office, that we would be oversizing my system by a large amount and potentially adding more heat and cooling into other rooms, at certain times of the day, and just creating problems the moment that we moved out of this office, right? So if I end up moving, which I'm not going to live in this house forever, if I end up moving, we designed this system as if it would just had a normal bedroom, okay? Because we wanted to design the house so that way the next person that moves into this home when we move eventually doesn't have a massively oversized system because of a computer system that they don't have. So no, I did not do anything extra to this room in my office that I have my computer system in. I just deal with it. It's not that bad. You know, basically, as long as I have my door open throughout the day, when I do come time in the middle of the summer to come in here and stream, today it's not that hot, but if I was going to stream, you know, it would be a little bit warm, but because I keep the door open with airflow and everything going through here all the time, it's not too bad, right? So it's just something I tolerate. In a perfect world, I'd love to have a system designed just for this room, but not at this time. So what else do we got going here? How often do I recommend cleaning the coils on a window unit? Actually, the window units probably need to be cleaned, especially the evaporators, quite often because they tend to have mildew and mold buildup inside the styrofoam around the evaporator. If it's one of the older mini splits, they typically have a lot of bacteria and buildup inside that styrofoam and around it. So the more you clean it, the longer it's going to last. But in reality, even though a window unit is still working and it's still cooling, it could be making you sick. So really, they're almost a consumable air conditioner. And I'm going to go out on a limb and say that you should probably be replacing every year and a half to 2 years because of the amount of bacteria and different things that can build up in those things. They are typically run in a really high humidity area and they just lead to nastiness. So I don't suggest keeping them for very long. I don't know. What do you guys think in the chat? Do you think that's a smart thing of me to say, or do you think that's silly that I say to throw a window air conditioner away at least every year and a half to 2 years? I mean, I realize it's still functioning, but I don't think it's going to be helping anybody with their health. Even if you clean it, the more you clean it, the better, I guess. But even if you clean it, those things are going to get nasty inside. What is up? Yeah, everybody's in here. Window units probably easier to replace than clean. You've never wasted the time. Yeah, that's true. I have cleaned window units, but for family members like my grandparents and stuff like that, because they, you know, they don't like change. They didn't like change when they were still around. So, you know, they just wanted their stuff cleaned. And I was like, all right, you know, we'll do it. All right, cool. Okay. So let me go through a couple more things. I already answered that one. Is there any good literature for working on variable frequency drives? This person is asking. So the Noel, I think, Hunico, I don't know if I butchered that name, but said any good VFD videos or literature that I recommend. Well, one of the cool things is that when I have questions or concerns about VFDs, I have a few friends that I could lean on, and a couple of those friends are in here right now. And I'll actually tell you right now that Jason Johnson, who's in the chat, or he was a little while ago, I saw him. Yeah, he's right there. He knows a lot and has a lot of good information, especially about train equipment when it comes to their VFDs and different things. So definitely go check out Jason's channel. Jason, make sure you throw a link to your channel and your stuff in here so people can see it. I know I'm seeing your stuff on Facebook. I'm seeing it on maybe Instagram, but I don't know if I see it on YouTube. So let the chat know and throw your links up there. But Jason can help you out. The other person is Holden Schamberger with HVAC Time. He's not in here right now, but Jason used to actually work with him. Holden has the YouTube channel HVAC Time, and he does a lot of great stuff and has a lot of that heavy industrial type content too. So he's another person to check out when it comes to VFD style stuff. Okay, yeah, Jason says it is on YouTube. Yeah. There you go. All right. Why? Okay, so someone messed up big time. That was the walk-in freezer that was never installed right, never commissioned, and it's marginally sized equipment. So the customer has a hard time maintaining temperatures when it's really hot in their kitchen. You know, just kind of stuff that happens in normal kitchens. So the equipment wasn't really designed with a greasy kitchen in mind. And so there's a couple questions with that, but why is there so much moisture in the box? Said Marino 924. So when I first had gone in there, when it was high in temp, there was a bunch of droplets and different things on the box. That's because there's a lot of condensation happening because they had a really warm kitchen. The equipment wasn't working right, and the customer was still going in and out. So they had warm, humid air coming into that box every time someone would open the door, and then it would accumulate up on the roof. The water droplets would come down, and then eventually it would start to freeze up again, right? But then when it starts getting hot in the day, same thing would happen. More moisture would come in. That adds to the moisture in those boxes. And that's why you see it is just because they were opening and closing the doors and it wasn't working right. So see what else we got going on in here. Okay. Okay. So going through there, what do I mean by a pump down system? Yeah. So You know, for the people that watch my videos, I do refrigeration and air conditioning for restaurants, okay? And my videos are generally meant for my employees, but obviously, okay, that's how they started. They mean a whole lot more now, right? We have you guys watching these, other people sharing them, all that good stuff, right? So I know that my videos are not just for my employees, but in my head, when I film them, I'm still thinking about I'm talking to my employees. They're not meant to be really DIY videos. They're not meant to be a basics introduction video. I don't think I'm that great at teaching basics and introductions. I show more real world technical skills kind of stuff, right? With a little bit of knowledge that I do have, and I can just relate it to how my brain troubleshoots. So, when I make my videos, I'm sometimes not thinking about people that don't really understand the refrigeration systems I'm working on. So the question is, what is a pump down system? Really simple question in my head, but sometimes I have to remember that not everybody knows that, and that's okay. So in a refrigeration system, something that we will do to stop liquid migration and just to help the system operate better, we will do a pump down circuit. Okay. So when the refrigeration system satisfies, when it's not needing cooling anymore, the refrigerant will then start to be isolated within a certain section of the system. And we do this typically by using a valve that shuts off the flow of refrigerant somewhere in the liquid line. Okay. And the system, though, continues to run because it's a pump down system. Pump down systems typically have a liquid line solenoid valve or a suction line solenoid valve, and they will have a thermostat. And basically, that they will have a receiver also, right? And so when the system pumps down, when the liquid line solenoid valve shuts down, the refrigerant continues to flow through the system as the compressor's pumping. The compressor's pulling that vapor back, and the low pressure is getting lower and lower and lower as it's running out of refrigerant, then the system shuts off. And then when it's time for the refrigerant to flow through the system again, the liquid line solenoid valve will open and that refrigerant will start to flow back, and it will activate the low pressure control and turn the compressor back on. And it'll run until it satisfies and do the same thing, right? So we can prevent refrigerant migration. We can prevent slugs to compressors and different stuff like that by pumping the system down and storing the refrigerant. Okay. Also helps to, keep oil where it's supposed to be, because that's another thing that can happen when you have refrigerant migration, is that the refrigerant can sometimes migrate to the evaporator. So when the compressor turns on, whoosh, a bunch of refrigerant comes back on the low side, sometimes as a liquid, and creates problems within the compressor. So, all right. Let's see. What else do we have going on in the chat? Reading through here. Do I think commercial kitchens should be using AON and sized with proper dehumidification in mind? John L. I think that a lot of my kitchens could very, very much benefit from higher end air conditioning systems, such as DOAS units, okay, 100% dedicated outside air systems. There's some companies that make them that do big, giant stuff, right? So let me read through here. Hold on a sec. I think, but anyway, so yeah, when you get those higher end units, you can have 100% outside air units that have really good dehumidification. They can help with air balance. They can do all sorts of things, right? When you have systems that are designed for that. So yeah, I think that systems like Aeons or Accurex or Captive Air or other major manufacturers that make 100% outside air units, Train, all the different companies. I think that it would benefit the restaurants to have those, but there's a high maintenance cost with those. There's a high skill required with installing and servicing those. And the more complicated you get on our equipment right now, at the rate that our trade is at, at the point that our trade is at with technical knowledge and basically bodies that are willing to work, we're running low on those right now, right? So having complicated systems like that on the smaller stuff like we deal with would lead to a lot of problems for these restaurants. And while it sounds great to have technology and efficiency, sometimes the return on investment isn't there in a quick enough amount of time. And with the restaurants, what they tend to find, in my opinion, is that if they go way too much technology, then the return on investment just doesn't exist because of a lot of different other issues. If they put those high-end units, then they have to or should be putting in high-end electrical systems protecting those, and they don't. So it leads to a lot of component failures, which leads to those units not paying off in the long run. So, all right, we answered that one. Let's see what else the chat has going on in here right now. The issue you have, oh, okay, you guys are having great conversation in there right now. That's cool. Okay, so Edge says, totally off topic, but working on a Berg chiller has type L90, but must have type K copper run to the condenser. Any ideas why? That I don't know. I mean, the type K is going to be, isn't that stronger? That's getting out of my realm of understanding or expertise. So I'm not really going to comment too much on that, but my logic would be that, like, I thought the type K was the thicker, more stronger copper, but again, I could be completely wrong. So, all right. Reading through the list of questions that I have right here. Let's see. Oh, this is a great question. So I had a video a couple weeks back on a beer walk-in that wasn't working right. The unit was off on high pressure because of a condenser fan motor failure. I cleaned the condenser. I think I may have changed pressure control or a contactor. I did something. I don't remember what. Somewhere in there. You guys can watch the video. But the beer walking is at 50 degrees was the name of it. So I mentioned in that video that they have a poor man's glycol system in there, right? And they have these booster fans that are installed right in front of the evaporators to catch the air and blow it into the beer taps. Okay. So this is a really great question. And I'll explain, what it is. But does the beer line air cooling use a single duct? Does it not create a vacuum in the cooler and draw warm air inside of the cooler? That is a great question. Okay. So I love that one because you're really, really thinking that through in your head. So his question is, when we put those booster fans and we take that air from the evaporator coil right in front of the walk-in evaporator and we push it through that little duct into the tap heads on the other side of the wall, does that air then leave the box and therefore make the box negative? Like, is it acting like an exhaust fan? No. Great question, though, because you're really thinking it through. That is a closed loop system. So there's a giant channel, round channel on the other side of the wall that makes a 90 and comes right back in. The beer lines run in and then out the other side. So it's not blowing the air out of the beer taps. It's just blowing the air through the beer taps across the beer lines as it exits the box for like 15 feet and comes back. And it just keeps the beer lines cold so that way they don't get foaming issues inside those little channels. So it's not putting the box into a negative pressure. And wow, I saw Jose, is it Jose Luigi? 123. Thank you very much for that super chat. That was really awesome, my friend. That's a very, very generous super chat. He says that he just wanted to say he appreciates me and the videos I make. Love hearing one of your coworkers who is also a newer tech. Oh, that's really nice. So he's saying that he has a coworker that will watches the videos too. So thank you very much, Jose. That's a very generous super chat, and I really do appreciate it. You definitely don't have to do that, but it is very much appreciated. So thank you. I love making these videos and sharing this little bit of knowledge that I have. What's the biggest systems that I've ever worked on? I don't work on big stuff. So about 35 tons, like this, I think pretty much like the smallest IntelliPack. I had a super tiny IntelliPack and a bunch of train equipment that I used to maintain. Kind of wish I knew more about them at the time. I didn't know very much about those systems, but they weren't functioning right. And we had to do all kinds of stuff to get them going. But yeah, 35 tons is about the biggest I've worked on. Everything under that. Reading through the chat. Let's see. Hayden says, thanks for posting these videos. That got you interested in refrigeration. You are now a service technician for Bassett Mechanical working on and hydrish systems. Is that anyways, I don't know how to pronounce that word. I don't know why I'm not saying that right, but that's really cool, man. I'm glad that you're interested in the trade. I'm glad that these could have been something to give you motivation to want to move further and stuff. So cool. All right, let's see. Ammonia. Okay. Yeah. Ammonia. That's what I thought it was, but for some reason I was having a hard time saying that word. Yeah. All right. I'm reading through the chat right now, reading through the questions right now. Oh, okay. So I had a video. Okay. Yeah. Another great thing. I had a video said the walk-in freezer wasn't cooling. It was the one that, I think it was the one that had the electrical problem underground, all that good stuff. Right. So in that video, I said a phrase, and you have to understand that my brain thinks in weird ways, and I often call things the wrong thing. Okay. So in that video, I said that sometimes these systems, I believe it was an intelligence system, they get stuck in this weird boot loop mode and they're not working right. Boot loop is not really the correct term, because a boot loop is where when you start up a computer system and it just constantly is at a boot up and then it turns off and then goes into a boot up. It's like a boot loop. It keeps happening over and over again. But that's not what that was actually happening in the system. When I said that intelligence system had like a weird boot loop mode, it was just basically my way of saying like it's just being weird. Okay, that's the point that I was making. So there's no technical term of boot loop that made sense in that situation that I was working on. It's just sometimes my brain fills in words and calls things weird things. So, all right. Okay. So what am I missing here, Ike? Oh, okay. So Ike is saying that he actually left his job. So Ike got into the trade, went to school, got into residential. And so he said that he actually left and he didn't like the way that the company was running. So interesting, bud. Interesting. Yeah. Message me. Let's talk some more about it. All right. Well, that is about it, guys. I'm going to cut this one a little short because I'm going to go cook some carne asada right now. So we're going to have some dinner tonight with the family. I made some salsa just before the stream and going to I'm going to have dinner with my youngest daughter and my wife because my oldest daughter is an adult now and she's got her own life and she's at work. And yeah, so we eat with our youngest daughter now. So cool. I am going to wrap it up. I really do appreciate everybody. Thank you so very much. Remember that I also go live on Friday evenings, work permitting, with my good friends Adam, Bill, and Joe over on the HVAC Overtime YouTube channel. It is a very uncensored, sometimes technical, most of the time not, talking live stream where we just four guys hang out. Sometimes we talk about work. Sometimes we talk about how many times I crap my pants. I mean, we talk about some weird stuff on that show. But check it out. Fridays, 6:05 p.m. Pacific. Again, really appreciate you guys. I'm going to cue up the outro music and we will definitely catch you on the next one.